In this video, I want to discuss products and quotients of rational expressions. All right, if you know how to multiply and divide fractions, then you're a big part of the way there to understand how to multiply and divide rational expressions. All right, so let's do a couple of examples. Suppose that we wanted to multiply 5 over 6 by 3x over 10y. Okay, now remember that if these were numbers, if both of these were numerical fractions, we would multiply the two numerators together and multiply the two denominators together. Now, variables don't get special treatment, so we're going to do the same thing. We're going to multiply 5 by 3x, and we're going to multiply 6 by 10y, and so the answer is 15x divided by 60y, and you can reduce that. 3x over 12y, you can reduce that even further, x over 4y. Okay, now, so that's how you do multiplication. So you see that with variables, it's not much different than if we didn't have variables. Now, what I would suggest is you reduce as fast as possible, because small numbers just make everybody's life easier. Okay, if I was doing this, what I would do is I would immediately, hopefully immediately, notice that 3 and 6, 6 divides into 3, so 3 over 6 is a half, so I can replace that with a 2 on bottom. And 5 over 10, that's also half, I can replace that with a 2 on bottom. I could leave a 1 on top if that helped you understand what I just did. What I basically did was I replaced 3 over 6 with a half and 5 over 10 with a half. Okay, now let's multiply 1 times x on top and 2 times y. Well, that's also x over 4y. See how we get the same answer? You get the same answer, but you do less work. That's why I would suggest reducing as fast as possible. All right? Okay, let's do now a division example. So suppose I had 6x divided by 5y, 6x over 5y, and I wanted to divide that fraction, that rational expression, by 21x over 15y. And I hope you remember that you can convert division to multiplication. So let's go ahead and do that. 6x over 5y multiplied by the reciprocal, the inverse, whatever you want to call it, 15y over 21x. And now we could multiply the numerators together and we could multiply the denominators together. Let's take advantage of my trick that I was just introducing to you. We have an x on top and an x on bottom. X over x is 1, so we can ignore that. Y over y is also 1. That's not going to do anything. 15 divided by 5 is 3. Okay, and now 3 divided by 21, I'm taking the 3 that I just wrote there. 3 over 21 is 1 over 7. You can leave a 1 on top if you like. Okay, so then we have 6 times 1 on top left over and a 7 on bottom. So 6 over 7 is the answer. Okay, I invite you to multiply it all out without reducing the fraction when I did, but later, and see that you get the same answer. All right? Now, you can also handle situations where you have binomials instead of letters, instead of simple variables, the way that I've shown you so far. So, for example, what about something like this? 5 times a minus b all over 8 multiplied by 12 over 10 times a minus b. Okay, and once again, we're going to cancel to make our lives easier. So the parenthesis blob on top divided by itself, that's going to give 1. Okay, 5 over 10, that's going to give a half. 12 over 2, that's going to give 6. 6 over 8, that's going to give 3 over 4. So the only thing left is a 3 on top and a 4 on bottom. Wasn't that fun? Okay? You're going to be doing lots of simplifying, reducing, canceling, whatever you want to call it, to handle these guys. Okay? What about a division now? Let's try that. So 9 minus p over 7 divided by 4 times p minus 9 over 21. Feel free to pause the video and try to solve this before I do. Okay, so I'm going to solve it now. I converted it to multiplication, and I'm going to reduce now. So 21 over 7 is 3. Now, we have a 9 minus p and a p minus 9. So they look similar, but they're not exactly the same, are they? Okay, so what I would suggest for that is you use what you hopefully remember, that if you have something like 4 minus 5 divided by 5 minus 4, you see that that's minus 1. Anytime you reverse the order of a difference on top and bottom, it turns out that that ratio is minus 1. So we can go ahead and cancel 9 minus p with p minus 9 as long as we add a minus 1 there. Okay, so now let's see what we have left. So we have, on top we have minus 1 times 3. On bottom we have, well, just a 4. All right. So far, all of the examples that I have given you, the numerator and denominator has been factored for you. Okay? If the numerator or denominator is not factored, you must factor it before you can reduce, cancel, simplify the way I've been doing. Okay? So you're going to want to immediately do that. Factor, factor, factor. Okay? Let me show you why factoring would be useful. So let's do an example of those. Okay, what about if I had x squared minus 4 over 25y, and I wanted to multiply that by 24y squared over x plus 2. So it doesn't look like there's much cancellation. You can, the y squared divided by y, that leaves a y on top. Okay, that's good. So it looks like that's the best we can do. However, what if we factored the x squared minus 4? Okay, we know that that's the difference of two squares. So let me go ahead and multiply x squared minus 4 by 24, but then I'm going to factor the binomial at the same time. Okay, can you see now that you can cancel the binomials? Now that we can cancel it because we've, again, it's in factored form. So the answer therefore is 24 times x minus 2 divided by 25. If you like, you can expand the numerator, but not necessary. Okay, and then let me finish by doing one that uses everything I've talked about so far. That might look like a crazy one. Okay, so what about x squared minus 2x minus 3 all over x squared plus 3x minus 4 divided by x squared minus x minus 6 all over x squared plus x minus 12. So I invite you to pause the video and try to see if you can get this answer before I do right now. Okay, so we're going to use a lot of the things I've talked about, if not everything. So the first thing I'm going to do is I'm going to turn it into multiplication. And actually, I'm going to factor and turn it into multiplication at the same time. Okay, so there, that blue rational expression is the first rational expression factored. Now, I'm going to factor the second rational expression and invert it at the same time. Okay, there you go. And so now we can have a big cancellation party. So we have x plus 4 is on top and bottom, x minus 3 is on top and bottom. Let's see, it looks like that is everything. So putting it all together, x plus 1 times x minus 3 all over x minus 1 times x plus 2. If you like, you can expand it, although that's not necessary. Maybe you think it looks nicer for some reason. And so you would get this if you like. So that whole black division problem we started with reduces, simplifies to this nice red rational expression. Okay?